All right, let's talk about something we all use every single day, but probably don't think much about: the power grid. It's this massive, sprawling network of steel and wire that feels, well, permanent. But what if I told you that the grid we see is actually hiding a colossal amount of untapped potential? Yeah, today, we're going to lock it.
So, is our grid holding out on us? The short answer is a resounding yes. Think of our power lines like highways for electricity. For decades, we've been running them with a permanent worst day of the year speed limit, even when it's 3 a.m. and the roads are totally clear. This creates these invisible traffic jams and leaves a huge amount of highway space completely unused.
And here's the culprit. It's a safety system called static line ratings, or SLRs for short. Basically, grid operators have to plan for the absolute worst possible day. I'm talking the hottest, most brutal summer afternoon with zero wind to cool the lines, and they set the power limit based on that single scenario. The problem? 99% of the time, it is not the worst day ever. So we're constantly choking off the grid's true potential because of this ultra-conservative fixed limit.
Okay, so when we do need more power, how have we traditionally solved this problem? Well, for a long time, the only answer was the brute force method. Just build more. Build bigger, build stronger, and, well, spend a ton of money. The two main old-school approaches have been, 1, reconductoring, which is basically just ripping out the old wires and swapping them with newer, beefier ones, and 2, building brand new double-circuit lines. Now, don't get me wrong, both of these work. They add capacity, but they are massive, hardware-heavy, and incredibly disruptive projects.
And when I say massive, I really mean massively expensive. Just look at these numbers. We are talking up to $1 million to upgrade 1 mile of wire. And building a new line, that can skyrocket to $5 million per mile. These are just staggering figures that make upgrading our grid at any real scale incredibly slow and painful.
And you know, the problems go way beyond just the money. These projects are logistical nightmares. They can take years to complete, they get bogged down in complex permitting, you have to shut down power to install them, and then you've got a whole new set of maintenance headaches. It's a 20th century solution trying to solve a 21st century problem. We desperately need a smarter way.
And that leads us to the first really big leap forward, a technology called dynamic line rating, or DLR. The core idea here is a total game changer. Stop focusing on building more and start getting more from what you already have.
So, instead of using those static, worst-case scenario assumptions, DLR puts physical sensors right on or near the power lines themselves. These little gadgets measure what's actually happening out there in real time, the true temperature, the actual wind speed, and from that, they calculate the line's real capacity, moment to moment. It's the first truly smart fix for our electrical highways.
So how do they work? Well, these sensors are all about collecting ground truth data. They're measuring the actual temperature of the wire, which is the biggest limiting factor. They're monitoring the sag and tension to make sure the line doesn't droop too low and become a safety hazard. And crucially, they're measuring the local weather, because just a little bit of wind can act like a fan, cooling the line and letting it carry way more power.
The results? They are seriously impressive. On average, DLR can unlock an extra 30 to 50% of capacity from the exact same wires. And on a really good, windy day, that number can jump to 200%. That is a mind-blowing increase in power, all without pouring a single ounce of new concrete or stringing a single new cable.
But DLR isn't the final answer. Because it's a hardware-centric solution, it comes with its own set of baggage. It's still pretty expensive. We're talking around $50,000 a mile. Installation can be a pain, and you've got to maintain all those sensors out in the rain and snow for years. It's a huge step up, but that reliance on physical hardware creates a new bottleneck.
And that brings us to the next evolution, which is a really fundamental shift from atoms to bits, from hardware to pure software. Welcome to the world of Digital Dynamic Line Rating, or DDLR.
This whole revolution starts with a simple but totally profound question. What if you could get all the benefits of that real-time data without having to bolt thousands of expensive sensors all over your grid? And the answer is the digital twin. DDLR creates a super precise virtual replica of the physical power line, all inside a computer. This digital model then simulates the line's behavior, estimating its capacity without ever needing to physically touch it. It's a completely software-driven approach. And the answer—
So instead of on-site sensors, this digital twin is constantly fed a stream of high-tech remote data.
It pulls incredibly detailed weather info from satellites and advanced meteorological models. It runs it all through sophisticated physics models that simulate how the wire heats, cools, and sags. And then it uses AI to constantly learn, refine its own models, and even predict capacity hours into the future.
Now, this software-only approach creates a really interesting trade-off. On the one hand, the advantages are incredible. It's wildly scalable, super cheap to deploy, and has zero physical maintenance. But it has an Achilles heel. Its accuracy is only as good as its computer model. And over time, a model can drift away from reality, becoming less accurate, which is a major risk when you're managing the power grid.
So what we have is a highly accurate but expensive hardware solution and a highly scalable but potentially inaccurate software solution. Which do you choose? Well, it turns out the smartest answer isn't either or, it's both. When you put these two technologies side by side, their strengths and weaknesses just pop right out. Sensor-based DLR gives you that undeniable ground truth accuracy, but it costs a lot and it's hard to scale. The digital twin, DDLR, gives you insane scalability for a low cost, but you're always worried about that model drift. They are almost perfect mirror images of each other.
And that leads to the ultimate solution, the hybrid model. Here's the genius of it. You deploy a small, really strategic number of physical sensors across your network, then you use their hyper-accurate real-world data to constantly calibrate and validate the system-wide digital twin. You get the massive scale of software, but it's anchored by the undeniable accuracy of hardware. It is truly the best of both worlds.
So, why does any of this tech wizardry actually matter? Because unlocking all this hidden capacity has huge, real-world benefits for every single one of us.
This quote right here says it all. By using this kind of smart technology, a single utility was able to put off a $50 million construction project. Think about that. Instead of spending tens of millions on new steel and wire, they just used data to unlock the capacity that was already there. That's a complete game changer.
Value just keeps stacking up. This technology lets us integrate way more renewable energy because the grid can finally adapt in real time to, say, a super windy day and accept all that clean power instead of having to waste it. It also makes the whole grid more reliable and stable, giving operators the data they need to see problems coming and keep the lights on for everyone.
We are finally moving away from a dumb grid of static steel to a dynamic, intelligent network that blends hardware and software. The technology is here, right now, to build a more efficient, more affordable, and cleaner energy system for all of us. The only question left is, are we ready to use it? Thanks for tuning in.